This is the second part of 9.3, and we're going to be looking at percent yield. So we're going to start off with theoretical yield. Yield just means how much of something do I make. So when I have a chemical reaction, how much of the product do I make? Theoretical means in theory, according to my reaction, how much of the product should I make based on the calculations, based on the math. We talked about cookies in class, about how a recipe might say you make 12 cookies, but you don't always make 12 cookies. Well, this is what the recipe says we should make. In theory, how much we should make. In all actuality, we don't always make the amount that the recipe or the reaction says that we should make. So the actual yield is when you actually do the experiment and carry out the reaction, how much is produced. So just like cookies, sometimes you don't always make the 12, sometimes you make a few less. And just like the um, with reactions, not all of it might react, or maybe there's some left in the bowl, like we talked about. So the actual yield is probably going to be less than the theoretical yield. If it's more, you've done some crazy kind of witch magic. But so the actual yield is probably going to be less. Now, the percent yield is looking at how much of the actual yield, how much of the theoretical did you get when you made the actual yield. So what percentage did you successfully make? So the equation is going to be actual yield divided by theoretical yield times 100, because we want it in a percentage. So you're going to be starting off your problems very similar to the limiting reactant problems. You'll have to figure out your limiting reactant first. This problem says when you have 36.8 grams of C6H6 react with an excess of Cl2, I'm going to stop right there. If that says that we have an excess of Cl2, that means Cl2 is our excess reactant, and that the C6H6 is the limiting reactant. So they have already figured that out, and they're nice. If they don't tell you which one's limiting, which one's excess, then you have to actually carry that part out. We do not have to do that here. All right, so we're going to start off with what they tell us we have, the 36.8 grams of C6H6. Okay, the actual yield, so I'm going to jot that down. Actual yield is 38.8 grams. What's the percent yield? Well, we know that the percent yield is going to be actual yield divided by theoretical yield times 100. We don't know the theoretical yield yet, but we have to calculate that. So first of all, we're going to take our limiting reactant, which they told us, and we're going to convert it to whatever they tell us the actual yield is. So they've got the actual yield is in grams, so we're going to have to go to grams of the C6H5Cl. So let's go ahead and do that part. So we're starting with grams of C6H6. We have to go to moles of C6H6. The mass of the C6H6 is 78 grams. And again, you get that from the chart. So moles of C6H6 is now on bottom. And we're going to go to moles of the C6H5Cl. The ratio, this is balanced, so it's 1:1. And remember, our actual yield was given in grams, so we have to take this to grams. So we have moles now on bottom of C6H5Cl, 2 grams of C6H5Cl. This is 1, and the mass of this is 112. And so we're ready to calculate. And if we do 36.8 divided by 78 times 112, we get 52.8 grams. This is our theoretical yield. So to find the percent yield, we're going to take actual yield, which they have to give you, divided by our theoretical yield that we just calculated times 100. And that gives us 73.5%. And that is our answer. All right, let's look at another one. Okay, so we have 75 grams of CO reacts to produce 68.4 grams of CH3OH. What is the percent yield? So here they're telling us that the CO is the limiting because they haven't told us anything about the H2. It reacts to produce this, so they're telling us this is our actual yield, and we have to calculate the percent yield. So 75 grams of CO, and we're going to take that to grams of CH3OH. Grams of CO on bottom to moles of CO on top. 1, and this is 28. So 1 mole of CO, and here we're going to 1 mole of CH3OH. And then we'll put 1 mole of the CH3OH on bottom, and grams of that on top, and the mass of that is 32. And then this turns out to be 85.7 grams. That's our theoretical yield. So if our actual yield is 68.4, our theoretical is the 85.7 times 100. Our percent for this is 79.8%. All right, let's look at one more. Al reacts with excess copper to sulfate. If we have 1.85 grams of aluminum react, and the percent yield of copper is 56.6%, what mass of copper is produced? So they're asking us, what's the actual yield? Because we can find the theoretical, they give us the percent. So percent yield is 56.6. Actual yield over theoretical, which we can find, times 100. So we're going to find the theoretical first and then kind of work backwards and find actual. So I'm going to jot this down. You should be decent at this by now. Aluminum's mass is 27. And it said we're working with copper. So 3 moles of copper on top and 2 moles of aluminum on bottom. And let's see, we need to go to grams. Mass of copper is 63.5. This ends up giving me 6.53 grams of copper. That is my theoretical yield, so I'm going to put it down here. So now I'm going to take 56.6 divided by 100 multiplied by this 6.53, and my actual yield turns out to be 3.69 grams.